Hello everybody, thanks for watching. I'm Brenda from group 208 and today you're gonna learn about color restoration. Yay! Well, first of all, you know that sometimes you get a picture but you forget to put the flash or something and it look really crappy because of the lack of light and you look like a bunch of black stuff. And well, that really sucks. Or, for example, when you had a picture and there's too much light, and yeah, you look like a bunch of white stuff. Yeah, that really sucks too. It's the same. Well, anyway, we can choose to fix that. How? Well, using two elements. Brightness and what else? Yeah, hue. Yay. First, concepts. Well, what you know and what you need to know. What you already know, I hope by now you already know what a solution is. A solution is a homogeneous mixture composed of a solid and a solvent that has a saturation point and can be classified as saturated, unsaturated, and supersaturated. You know, easy peasy. What you don't know, and I will teach you today, are the words that are in my bag. Here, you know, that works. Well, we're gonna see it right now, don't panic. Well, first of all, what color? You may have an idea of what color is, but I'll tell you anyway. Well, you know that color is like light, and light is energy. So energy manifests in waves. Of course, the human eye isn't able to see all the waves. I mean, there are like too big wave or a small tiny little wave, but in what a visible range we're talking about, well, here it goes from red, there is like a little whiter, and it goes all the rainbow colors and stops in the violet color, and well, the violet is like a bit of tight, and I mean not that tiny, but okay. So now you know what color really is. Well, I hope. I can teach you about color saturation. What's color saturation? Well, it's just the amount of pureness there's in a color. How? Well, this is measured in percentage. For example, the primary color there will be the 100 percentage, and if it goes down right here, it will get to the white. Well, brightness. It's just the amount of light or bright or light or whatnot there's in a color. For example, here, brightness, the lightness, brightness or whatever is changing from here to there, and the saturation is decreasing from here to there, and the hue is changing all around the circles. Wait, what's hue? Well, don't panic, here it is. Hue is the name of a certain color. For example, this hue slash color is red. This hue slash color is green. This hue is yellow. This one is orange. This hue is blue slash color. Whatever. I mean, the hue of the word I covering with my body is changing. I hope you see it. It's really pretty. As well as the stars from red to yellow to whatnot, it's changing. For example, when you change the hue of a picture, you're changing the color, and that's what it looked like. I mean, the principal color, it's like this one. I mean, well. Digital image, what's that? Well, I think you know by now what a digital image is. It's just a picture of a computer or here a TV or whatever that has been digitalized. What does it mean that it's being composed by pixels? Where's pixel? Well, it's just a tiny little bit of information, a color, and it's what is made of that digital picture. I mean, there are too many, like a billion or so, I don't know, and it will form a picture, and they are too tiny for us to see. For example, here the Mario I'm covering with my body is like made of, I don't know, 50 or so pixels. It's really pretty, don't it? Okay. Well, I need you to know what a color model is. Why? Because I need you to compare two of them. First of all, what's a color model? Yeah, a color model is just the way of associating names or numbers or letters or whatnot with a color. It's like you're naming the color. It's because, well, there's a bunch of colors and each one is different. For example, here These two blues are practically the same, but they are not. Why? Because the name is different, and God only knows how it's different. But yeah, it's different. Here, the black color is like a bunch of zero. It's just like in your photo log when you wanna change the color of your photo log, you put the name of the color, and well, it'll get you the color. Uh, for example, there are like a zillion greens, but if you want a certain one, you have to say, well, I want the whatever blah 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 color, and well, if you get you, it will get you the green, whatever. Well, the RGB color model. This is the first of two color model I want you to see. This color model is a very important thing of it is that it uses light. How? Well, it can be natural like this picture, or it can be artificial like the TV or the computer or whatnot. This video. Yeah. So using the light, it will mix the R that stands for red, the green that stands for D or whatever, and the B that stands for blue. So these three colors will form you the white. I mean, all colors form the white, yeah. And the absence of color will form you the black color. And yeah, this is an adaptive color model. Why? Because adding all the colors will get you to white. Remember that, please. Okay, now a totally different opposite color model. The CMYK color model. Wait, what's that? Well, yeah. C stands for cyan, that is kind of baby pink, right here. Magenta, that I mean it's like pink. Yellow, that well I think you know what yellow is. And key, well this is just the opposite. Why? First of all, because it don't use light at all. I mean, this system is used in printers for printed material, and well it uses three inks to form the black color, the key color. So it's totally different. This is a subtracted color model because subtracting all the color will get you to the white. Of course, if you had a color sheet, it will get you to the color sheet, but mainly to the white if you are using white sheets. Yeah. Well, you may ask, how do they get the baby pink? I mean, if they only had the magenta, and it is a really strong color. Well, the printers has a DAT system. What's that? Well, for us to see the baby pink, they had to distribute the dots, separate them from each other, and like they are very tiny, so we only see the baby pink. And it's really cool, yeah. I mean, it's not like the printer has like all the colors. I mean, each ink, it's not. I mean, it used all three colors to form all rainbow colors. I mean, it's really cool. Comparing and summing up. Well, RGB, CMYK, totally different. RGB has light, this doesn't. This just the colors to form white. This just all the colors to form black. As I already said, white, black, black, white. Okay. My hypothesis. Well, my hypothesis was that changing the color, I mean the hue of picture or the brightness or whatnot will affect its quality. And well, I discovered that this is not true, because there are many factors that affect the quality of your picture. And if you change the picture from being like a bunch of black shadows, I mean from a really cool picture, it really doesn't matter. It's cool to do it. So conclusion, well, as I already said, it doesn't matter that much. And well, I also learned that by using the RGB color model right here, you can get more saturation. Why? Well, because it just is light. I mean, the bright light, and yeah, whatever. The CMYK, on the other hand, it's very different. How do I compare with solutions? Well, the RGB color model is not that related. Why? Because it uses energy. I mean, it uses light, and solutions just matter. So that's why I touch about the CMYK color model, because it just matter. I mean, little drops of ink put up together to form a product or a color. So depending of the reactants, or I mean how much cyan or yellow or whatnot you add to a sheet, it will get you to a different product. So I thank you for, yeah, thank you for watching.